So in class last time, you got to look at the relationship between linear speed and angular speed. The linear speed, like we learned first in earth science, speed is distance divided by time. And angular speed is similar. Omega for angular speed is angle divided by time. What we're going to look at now is what do you do when you have both of these kind of meeting up in the same situation. So just as a quick example, just to kind of get our brains warmed up, imagine that you've got a bicycle wheel. Here's the center and here are the spokes. And I'm not the greatest artist in the world, but hey, you get the idea, right? And let's suppose that this bicycle wheel is turning with an angular speed of 1.4 RPM, revolutions per minute. So if you wanted, you could rewrite that as 1.4 revolutions each minute. And it's a ratio. And suppose I wanted to know if I gave this thing 4 minutes. What revolutions does it complete? Well, that's not too hard. We know that that speed is angle divided by time. So if I rewrite this formula a little bit, if I take this formula and I multiply both sides by time, then here time cancels with time and I get angular speed multiplied by time equals the angle it goes through. So now I could plug that in and I could say angular speed, well, the angular speed is 1.4 revolutions per minute, 1.4 revolutions per minute, times time, and the time here is 4 minutes. You might want to think of that as 4 minutes over 1, just to help you see how the fractions line up, is going to give me the angle that it traveled through. Now if you take a look over here, look at your unit analysis. Minutes in the numerator cancel out with minutes in the denominator. So I'm just left with 1.4 times 4, which is 5.6 revolutions is the angle it traveled through. Now, a common question you're going to be asked, instead of in revolutions, you might be asked to describe how far it is turned in radians. So what if we had this same problem, but I change it just a little bit? I'm going to change this problem just a little bit. In 4 minutes, how many radians does the wheel turn? Well, we already know that it's 5.6 revolutions. We just figured that out. And what I want to do now is I want to reach back into some other things that I learned in chemistry and in earth science and in physics, how to do a unit conversion. Because 5.6 revolutions, that is an angle. It's just not an angle in radians. But remember, we know that 1 revolution, 1 complete turn, is 2 pi radians. So I can figure out my answer just by saying, well, the angle is 5.6 revolutions, and then I need a unit conversion. Now remember, when you do a unit conversion, you want to put the thing you're getting rid of on the bottom and the thing you want to get on the top. So I want to get radians. I'm going to put radians on top, and I want to get rid of revolutions. So revolutions go on the bottom. 1 revolution is 2 pi radians. And now, again, I can put that over 1. I have revolutions cancel out, and I get 5.6 times 2 pi gives me 11.2 pi radians. And so the wheel in 4 minutes has turned 11.2 pi radians. And if I wanted, I could grab a calculator and multiply 11.2 times pi and get a decimal approximation, but I'm also okay with just writing down this exact answer and leaving it like that. Now, let's take this whole idea a step further now. We know angular speed, we know linear speed. What about situations where angular speed and linear speed are happening at the same time? Oh my goodness, what would that look like? Well, let's suppose that here you are, and you're happy, and here is a weight that you need to lift up. And the way you're going to do that is attached to the ceiling, you have a pulley. So there's a rope coming down here, and it's attached to the box that you need to lift, and that rope goes over the top of the wheel, and it comes down into your hands, and you're going to pull that rope in. Now let's suppose that, I had to write my numbers down for this one, let's suppose that you are going to pull in 8 feet of rope. Well, then how much is this box going to go up? You pull in 8 feet of rope, the rope passes over this wheel, the box is going to go up, you got it, 8 feet. But what about this wheel? How much does the wheel turn? Well, to answer that question, I'm going to need to remember that each revolution is 2 pi radians, and I'm going to need to know how big that wheel is, because a big wheel isn't going to turn as much when I pull in those 8 feet as a little wheel would turn. So I'm going to tell you now that the radius of this wheel is 1/2 foot. 6 inches, but I'm going to write it as 1/2 foot so that I've got it in the same units as that. I could also write 6 inches. Well, now I've got all the pieces I need. I know that 8 feet have gone by on the outer edge of the wheel because 8 feet of rope have turned the wheel. So I know that the linear distance is 8 feet. But what is that to the wheel? Well, what I'm trying to figure out is what angle is that? What angle would make this wheel turn 8 feet? So to understand that, I got to take another step back just for a minute, and I need to think about this wheel. So let's look just at the wheel up close. Here's our wheel, and its radius is 0.5 feet. And the distance all the way around it, well, that's the circumference. And I know from geometry that circumference is 2 times pi times the radius. So the circumference in this case is 2 times pi times 1/2. So the circumference in this case is pi feet. So we know that the wheel went 8 feet, and each pi feet is 1 revolution because the circumference is the same thing as a revolution. So now I can say 8 feet pi feet is 1 revolution. Now see how I've set up my unit conversion again. Feet in the top, canceling out with feet in the bottom. And so now I have 8 revolutions over pi is the angle. Our wheel has turned 8 revolutions over pi. Now what if you want that in radians? No problem. We have 8 revolutions over pi. And I know right here, 2 pi radians is a revolution. So I'm going to put revolutions on bottom. I'm going to put radians on top. 2 pi goes with the radians 1 goes with the revolutions, and now revolutions cancel with revolutions, but also pi cancels with pi, and I get 16 radians. The wheel has turned 16 radians. So here we have a linear relationship, feet, meeting up with a rotational relationship, radians or revolutions. Let's take a look at one third example here. Let's say you're out in the yard, you got to wind up a hose, right? So you got a hose trailing across the ground. We'll pretend that's a hose, right? And then you got a little device over here and you're going to wind that hose up around that sucker. So you're turning the handle like this. You got a hold of the handle and you're turning the handle, and you are turning that handle at a rate of 12 revolutions per minute. And what I want to know is how fast is the hose being reeled. Well, I'm turning this at 12 revolutions per minute, but that's not quite enough information. What else do I need to know? Think about it. That's right, I need to know the radius of the wheel. So now I need to tell you that this wheel that you're wrapping the hose around has a radius of 4 inches. Radius is 4 inches. Okay, so now we know that the radius is 4 inches. Just like before, I'm going to use that to find the circumference. Since the radius is 4 inches, that tells me that the circumference is 2 times pi times r. So the circumference is 2 times pi times 4 inches. So the circumference is 8 pi inches. So that's the distance around. Now, we need to convert that over into how fast the hose is getting reeled in. So now I'm going to take my revolutions per minute. I have 12 revolutions every minute. And that's my starting point. But what I want to end up with is how fast the rope is being reeled in. So let's see. Well, what do I know about a revolution? I know that 1 revolution is the same thing as 1 circumference. So 1 revolution is the same thing as 8 pi inches. And now you notice revolutions cancel out. So I have 12 times 8, that's 96 times pi inches each minute. And so I've taken an angular rotation, 12 revolutions per minute, and turned it into a linear speed of 96 pi inches per minute. So that's the basic idea of how you connect angular motion in angle per time to linear motion, distance per time.